Hi, I'm Daz. Looking through my shelves of unstarted projects. This is an Ekco PT208 from around 1961 or so-ish. Could be 62, could be 63, I'm told. I've got a couple of these. This one has the Newmarket transistors in, so I thought perhaps we'll try a power up, a very careful power up, and just see what happens with it. Okay, so here's with the back off. First thing I notice is it looks like it's been subject to some damp at some time, because fortunately the wood has split here. I can't see any corrosion on the electronics, so that might be okay. There's definitely some cobwebs in here. And here's the battery terminals. I've checked, it's 9 volts. I imagine it was one of those, was it a PP6? I can't remember now. The smaller 9 volt one, but that's what I believed it used. So perhaps a gradual bring up on the power supply with current limit and just see what happens. Further note, this one is fitted with a car radio socket. That was quite usual in these times because car radios were very rarely fitted in cars unless you bought the top model. So quite often a transistor radio like this was put in use inside a car, and hence it's got one. It's got a long and medium wave switch here and on-off volume. So clicked on, I'm going to bring it up gradually. I've got the volume full. Okay, here goes. Now starting 1 volt action. About 10 milliamp all the way up to 9 volts. Oh, yes. Very, very weak station. That is my local station. So we have some action. It's drawing about 10 milliamps. That is tuning a station. It's about the right place on the dial, so I expect that we're lacking gain somewhere along the line here. I can definitely hear a healthy bit of hiss from the amplifier, so that's good stuff. Fortunately, someone on the vintage radio forum has put some instructions on how to get this apart. So it'll be these 2 screws here first, followed by the P-clip, so I'm going to get on with that. Fortunately for me, this screw is already loose, so I'm going to undo that. And does this pull off? Oh yeah, this could be fun, couldn't it? 1960s plastic. Ooh, I think I'm putting far too much tension on this. It's coming. Ooh, come on, please don't snap. This is where you need patience, something I need to learn more of, I think. There we go. Thankfully that didn't break. Okay, I can see another screw now. So what have we got? But I assume that comes undone next. Right. Ooh. Oop, that's just fell off. lots of wires attached, and there we go. Well, clearly my wireless and electrical trader sheet is a little bit out of date. I perhaps I need to read it, but it shows a resistive biasing on the output stage, and here we've got an NKT diode. Yeah, it's the usual trick. What they used to do is if they had a transistor with a duff junction, they used to use it as a diode, and that's what I can see there, because there's a cable being cut on the transistor itself. So it looks like it's got all the original electrolytics in here. Natty little IF cores. This has got 2 IF stages, 3 transistors in the output stage, and a mixer converter. So, well, I've been through the voltages on the 2 IF stages, and they're not exactly what the manual says, but they don't really look too far out. That capacitor, yeah, blowing its end off. Yes, I could change the electrolytics, but at this moment in time I don't think they're the cause of my problem. Sleeving colour coded on transistors, I should have noticed that. Red is collector, yellow is emitter, and green is base. So what I think I might do now is inject some IF, and it's 470 into the base. Just wondering if I could use a scope probe. I never thought of using that. It's isolated and it's got attenuation, so that might just do the job. Okay, so I'm injecting a signal from my generator into the first IF, and the scope probe is connected to the RF bypass capacitor, which is after the rectifier diode that's used to rectify the RF, turn it into audio. And just hit my head on the light. You can see I've got a very healthy signal there, hundreds of millivolts. So why is the audio so low? Well, maybe there's something else I haven't spotted there. So maybe I need to now look at the RF stage, the AF stage, and see what's going on there. I'm now looking at the centre of the volume control. Interesting, the volume from the speaker isn't altering much. So that's good. Okay, so it's a good signal there. Well, I've just been tracing the circuit from the volume control down this pink wire, and then discovered it goes through this capacitor here, and that capacitor is coupled to this IF stage. So I haven't got the radio I thought I had the circuit for. This appears to have, if I've got my facts right, a reflex stage, i.e. an IF stage that amplifies the intermittent frequency and the audio. So the audio is disappearing in there and not coming out, so I'm going to have to do a bit more circuit tracing or find a different manual. Oops. Oh well. Could explain my puzzlement. Stay on. Well, that 5 microfarad is obviously open circuit, so I'm going to have to replace that. Yeah, that's obviously quite small then. Okay, here's the audio return path from that IF stage. It's that yellow wire, resistor and a capacitor. Now, that's one side. of the capacitor, and the other side of the capacitor, nothing again. So I reckon we've got another open circuit capacitor there, so another one to replace. That certainly sounds a little bit stronger. So I wonder now, I keep wobbling the camera, take the IF injection off.
What's the power? Metropolitan Police Service to it. People who
Sounds good. We're now getting what sounds like more decent reception. Right, well definitely there's distortion there. Now I wonder if, looking at this, there's another one hidden down there. Now what's the betting? Let's have a look. C12, 8 microfarad. Okay. I'm going to have a look at it with the scope. Well, I think it's fairly obvious that other capacitor's got as well, because that's the automatic volume control line, and that should be just DC being fed back to the IF. So I think that capacitor's gone open circuit there as well. That's a bit more like it now. As you can see, we've got a DC as I tune over the radio station, so that's what we should have. So yeah, that capacitor was open as well. Would it have been easier just to change all the capacitors? Yeah, maybe. Wouldn't be so much fun though. Well, time to do IF alignment. It's this one, and this one in order of injecting the 470 kilohertz in across L3 it says, and that's a point here where this Hunt's capacitor is, and I didn't notice that. I hope it's not too leaky. But, if it was, we wouldn't be functioning, so it cannot be that leaky. So I'm just going to go through here and monitor it on the scope and just adjust for the highest output. I've decided to replace this Hunt's capacitor. It is leaking. I managed to find a 39 nanofarad to replace it, so that's now been replaced. I'm just putting it back together as per instructions for the PT208. Ref realigning it. I don't know if you can see that. I shall try my hardest. You can see the presets there, and you can get hold of them through this gap through the side and adjust the local oscillator and the tracking. So that's what I'm going to have a go at next. I've just had a look through my radio and television books and found the diagram for a PT208, and that appears to be a little closer to what I've got with the biasing and the reflex back through the IF stage. So I think that's a little bit clearer now. I think that's a bit clearer to the set I actually have got here, and of course it shows the diode bias on the push-pull output stage. So now I'm going to just use a coupling loop and just go through the procedure. I've just got to make sure I can identify which are the right two capacitors there, and make a start on that. I'm just going for the first set of adjustments. It calls to adjust the local oscillator, which you can see the tool in the back for the coil on the PCB. It also it also calls for adjustment of the ferrite rod. The thing is, I can't really get much of an access to it really, so I may just leave that and just set up the local oscillator. I'm at 600 kilohertz and I'm tuned to 500 meters. I've got a bit of a rustling noise, but I think that might be because the scope's attached, but wow, I'll turn the volume down a bit. So the local oscillator was obviously out a little bit, so that's that part done now. Right, now it calls for the usual 1500 kilohertz and then adjust C9, and it told me C2 is the top one, so it's going to be this one down here I'm going to adjust next. Well, I'm just going to have a go at C2 now. It's called for me to tune to 1.4 megahertz or 1400 and then adjust the C2. And, ooh, that looks like that's a little stiff. That's a bit better. I've already repeated the local oscillator at both ends, and that seems to be pretty good on tracking. This is proving a little bit more difficult. Right, I think that's about best I'm going to get it for now. I'm going to have a listen to see if this keeps rustling. I'm a little concerned about this rustling noise I'm still getting. I don't know how good the microphone is on the camcorder, but I've shorted out the volume control down to ground, which is positive in this case, and there is a little bit of crackling going on and popping. Unfortunately I've run out of freezer spray, so I'm not able to spray, but with the volume control shorted out it's going to be VT3, which is the IF and AF stage, the reflex stage, this driver transistor, or the two outputs, or possibly something else, possibly a noisy resistor, but so far I haven't had a lot of luck in tracing it, but I'll continue looking. So just to recap, so that's the push-pull output stage, that's the audio pre-driver there, so then this is the last IF stage, which is also used as the reflex audio stage. I've shunted out the input to this driver, and the crackling has stopped. As soon as I release it, it's starting to crackle and pop again. So I'm guessing that there's something wrong around this reflex stage, because since I've got the input to it shortened out, the crackling is coming from somewhere here. It could be a resistor, could be the transistor. I'm just not sure at this moment, but it's certainly crackling nicely. Might even be a bad joint, because yeah, the audio is picked up from a collector resistor, very low, 82 ohms. So any variation of current through VT3 is going to cause it's crackling nicely now, isn't it? Interesting. Well, it's interesting. What I've done now is I've actually grounded the base to the emitter of VT3, the audio amplifier IF stage. I'm still hearing loud crackling from time to time, so that's interesting. And there is DC still travelling through the collector resistor here, so maybe it's got a sort of leak, collector emitter leak. Well, all germanium transistors do, I guess, to a certain extent, but I just wonder if it's intermittent. I really need to get some freezer spray. I couldn't find an NKT 164, but I had an NKT 163 that I've now put in the reflex IF AF, that's a bit of a mouthful, stage. I've just been listening, I've heard no signs of crackling. Yeah, I know it's the wrong transistor, but needs must, so it'll just be a case of seeing if it's any good now. But certainly it's picking up some nice switch mode interference at the moment. I think I know what that's caused by, so I'll unplug it. But that's Radio Caroline, so the sensitivity isn't half that bad, so perhaps I'll live with that. As you can see, I'm running the radio. It's a PP6 this radio should take. I thought it was PP7 when I first looked at it, but it's PP6. At the moment I've got a PP9 adapter on, and I've got 6 A cells in, which I guess this is pretty much similar to the size of the original battery that should have been in there. So just been sitting here enjoying this radio. Anyway, I thought I'd just draw out a basic part of the circuit so I can see what's going on with this reflex circuit. This is the last IF transistor, and as you can see, it's conventionally connected. The transformer's in the collector and tune circuit. There's your output winding, and it goes through a diode and resistor and to volume control. So obviously that's rectifying the intermediate frequency and demodulating it into audio. It then goes through this volume control, and then goes through this electrolytic here, and then back into the bottom part of the bias of the intermediate frequency transistor. So effectively you've got a bypass there of 0.04 microfarad, so that's making sure that no intermediate frequency is being developed across there, but you're able to put audio in, and also that also stops any intermediate frequency that might be coming through here as well, because if you had enough intermediate frequency coming back through, it's obviously going to oscillate. So yeah, so the audio is injected into this resistor here and finds its way through the IF transformer, because of course at audio frequencies it's not going to have any effect, and back into this transistor. If you look at the collector, there's an 82 ohm resistor. It's about 200 millivolts across that, so you're not going to have a very large audio signal there because you're going to clip. But then that goes, it's bypassed again, make sure there's no intermediate frequency there, through a resistor, capacitor, and into the first IF stage. So that's a reflex stage, and that's how the transistor doing the final IF is reused as a extra AF transistor. And you know, you think back to the 60s, transistors were expensive, so this is a good way of saving the cost of an extra transistor. Plus you've got two AF frequency transistors in the loop to drive your push-pull. So that's you know, a clever little way of getting a little bit more audio gain. But I guess the complications of making sure you don't end up with causing a feedback in this intermediate frequency stage are quite complex. But no, so that's how that works. So it's quite fascinating. I had the wrong circuit diagram for a start. Now I've got this one. I can see that this one has got the reflex circuitry in. Anyway, I hope that's of some interest, because I mentioned reflex circuitry and some people might wonder what on earth I'm talking about. I think people wonder what I'm talking about most of the time in any case. Right, well, I stuck a replacement bit of sponge in here. I just used double-sided sticky tape. I think that's adequate, so I think hopefully, yeah, that's not a bad fit, is it, in place of the original battery. I think that'll work with a bit of foam stuck back on this side of it. I think that'll be fine. Yes, note this receiver is capable of excellent sound quality and volume. However, the battery will last longer if the volume is limited to the minimum required for reasonable listening. That's cool. Right, so I'll stick a bit of foam on this side, I think. Yep. Right, good. I'd say that one's working now. Very pleased to get this one working. It contains Newmarket Transistors. Newmarket Transistors was quite local to where I am, and I know people who work there. So it's good to get this radio working with the original transistors in it. Bit of history for me, I guess. So that's good news, that one's working, but I need to remember to take the batteries out when I'm not using it. I don't want them leaking in it, but yeah, not a bad little radio. I quite like it. There's a little bit of bass response there with that large speaker. So yeah, I'm quite happy with the Ekco. Anyway, thanks for watching, and it's nice to do something that wasn't a tape recorder.